Hi everyone, welcome to lecture 21 of your circuits class. And we will continue with RC circuits. And the purpose of the lecture over here, we will have these objectives. So use the step-by-step approach to solve for voltages or currents in RC circuits when the circuit has dependent sources in them. So this is what we will do. So let us go over an example here. And let's say that the question is asking us to find the voltage V of t for t greater than 0. And our circuit is this. Plus, minus, this is 2ix, this is 3 ohm, 6 ohm, over here we have a 12 volts, and our ix is flowing here. And this is our switch, so it's going this way at t is equal to 0. So the switch was open and it closed at t is equal to 0. And this is where we need to find our V of t across the capacitor. And the capacitor value here is 0.05 farad. So this is what we need to solve. So our solution here, we'll start with step 1. We said that assume a solution of, since the requirement is V of t, so we will write V of t is equal to V of infinity plus V of 0 plus minus V of infinity multiplied by the exponential of negative t over tau. That is step 1. Step 2, draw the circuit before switch action. Replace capacitor by an open circuit. And find VC of 0 minus. So this is our circuit for this step. This is the capacitor, it is open, so we need to find VC of 0 minus. The switch was open. So that since this is open, this one does not matter, right? Doesn't matter at all. So this is a 3 ohm, 6 ohm, and we need to find VC of 0 minus. So in this case, if you look at VC of 0 minus, that is open, no current, which means no voltage drops across resistors, which means that all the voltage will be across the open circuit. That means our VC of 0 minus is equal to 12 volts. Step 3. Draw the circuit after switch action. Replace the opening with a voltage source, which is VC of 0 plus is equal to VC of 0 minus, and then find V of 0 plus. So this is our circuit. The switch is closed. This is 12 volts, 6 ohm, 3 ohm, 12 volts, 2 IX, and this is IX. So this is what we need. We need V of 0 plus. So in this case, V of 0 plus is equal to 12 volts. Step 4. Draw the circuit. In step 3, replace VC of 0 plus by an open circuit. Find V of infinity. So this is our circuit here. That is open for the capacitor. Two IX, 3 ohm, 6 ohm, 12 volts, and this is the direction of IX. So we will have, let's say, a loop current here. So what we need to find is this voltage here, which is V of infinity. So let's say that we will have our IX here. This is open, so there is no loop in that side of the circuit. So loop IX, that will be and we are putting it in the same direction of IX, so it is counterclockwise. So we will write our equation. That is a 12 minus 2IX plus 6IX is equal to 0. So that is a 12 plus 4ix is equal to 0. That means really ix or 4ix is equal to negative 12, and ix is equal to negative 12 over 4, which is equal to negative 3 ampere. So that means our voltage source of 2ix is equal to 2 times negative 3, that is equal to negative 6 volts. So if you look at this value here, that is negative 6 volts, and V infinity, the opening over here across that negative 6 volts, that means V infinity is negative 6. Step 5. Step 5 is find R Thevenin. How we are going to find R Thevenin? We have over here the circuit has a dependent source plus independent source. That means we are gonna need to find I short circuit and V Thevenin. Then R Thevenin is equal to V Thevenin divided by I short circuit. So let us find I short circuit. To find I short circuit, we need to draw our circuit. (12 volts, 6 ohm, 2ix, 3 ohm, and this is where our capacitor, so we need to short it and find I short circuit. And this is our Ix. So we are gonna have our Ix to be counterclockwise, and we will have our I short circuit to be clockwise. That is, these are just assumptions. We can assume whatever that we like. So loop Ix, that is 12 minus 2ix plus 6ix is equal to 0. And 12 plus 4ix is equal to 0. So 4ix is equal negative 12, and ix is equal negative 12 over 4, and that is negative 3 ampere. So from that, the source 2ix is equal to 2 times negative 3, that is equal to negative 6 volts. So loop I short circuit, negative 2ix plus 3I short circuit, that is equal to 0. So minus negative 6 plus 3I short circuit is equal to 0, which means that 3I short circuit is equal to negative 6, and our I short circuit is equal negative 6 over 3, which is equal to negative 2 ampere. So now If you remember, the second step is to find V Thevenin. However, V Thevenin is V of infinity in this problem. Because it happens to be the voltage across the capacitor. So V Thevenin is equal to V infinity, and that is equal to -6 volts. So from that, our R Thevenin is equal to V Thevenin divided by I short circuit, and that is equal to -6 divided by -2, and that is equal to 3 ohm. So this is our R Thevenin. So now step number 6 is to find the time constant, which is find tau. We know that for RC circuit that tau is equal to R Thevenin times C, and that is equal to 3 times 0.05 farad, and that is equal to 0.15 seconds. Step 7, evaluate step 1. So V of t is equal to V of infinity plus V of 0 plus minus V of infinity times exponential of -t over tau. And in this case, that is equal to -6 plus 12 minus -6 exponential of -t divided by 0.15. And that is equal to -6 plus 18 exponential of -6.67 t. That is in volts. And this is our answer. Maybe you wonder why use RC circuits. The reason for that, this is one application. Which is, let's say, the wiper blades. What we mean by that, if I have the voltage of the car here, I have, let's say, a capacitor over here, then we can have a resistor bank. That is one resistor. This is, let's say, the second resistor, and this is the third resistor. So if you can see, if I have, for example, this as 1K, this is 5K, and this is 10K. So now, if I am gonna have that connected to this K, and let's say, for example, if this is 1 microfarad, then our tau in this case is equal to 1K times 1 micro, which is 1 millisecond. So that means the capacitor will charge in 1 millisecond and discharge in 1 millisecond. Then if we connect that over here, then our tau is equal to 5K times 1 macro, that will be 5 milliseconds, which means that the capacitor will charge in 5 milliseconds and will discharge in 5 milliseconds. And then if we connect that at 10K times 1 macro, that is 10 milliseconds. And this is where you have, for example, the knob in your car for the wiper blade. Let's say that if you are gonna have it at this speed or this speed or this speed, that it will give you different speeds. That is based on this circuit and based on this time constant. So the lower the value of tau is, the faster the blades will go. Clear? That is one application. By this, our lecture 21 is done, and this is your homework for that. Thank you for watching.